Session. Yeah. So what we have discussed in our previous sessions, we have started with number system discussion, and we have, just explored about the different kind of number systems, and we also had a test, and we have discussed the answers related to that particular test and all. So yeah, let me share my screen. 1 second. So this is what we have started about, and yeah, also we have seen about different kind of number representations. Give me 1 second. And we have seen about different kind of number systems and all. And I hope my screen is visible, right? Yeah. So we have seen about different kind of number systems like signed, ones complement, two's complement, and SMG format. And we have also seen about the ranges of this particular numbers, and we have discussed about one's complement and two's complement, and the ranges also we have discussed it in great detail, right? Now, let's discuss about like if we have a negative number and if we have a requirement of addition, adding with it. So how we are going to make that particular, subtraction and all. Okay. Now, let's say if I'm going to have a particular number A is equal to, let's say, plus 5, and B is equal to minus 4. So instead of just, subtracting A minus B, we can just perform A plus 1's complement of B. This is very, very useful when we are going to discuss about, other kind, when we are going to discuss about Verilog coding, and when we are discussing about some kind of algorithms. Instead of subtracting, you can just use the same adder, and you can basically perform A plus 1's complement of B. You're going to perform A minus B itself. Okay. For example, let's say, first of all, let's see how to perform this particular operation. So whatever the number which is a positive number, you're going to write down as it is. So what is the value of A, guys? How many bits should we take for A? Whether it is 3 bits, 4 bits, 5 bits, what is the value should we take? How many bits should we take if we are representing it in one's complement format? 4 bit. Okay. So it's nothing but 0, 1, 0, 1. Can I take 3 bits to represent plus 5? Is it correct to take 3 bits for representing plus 5? Like, can I take 101 for representing plus 5 in one's complement format of representation? Any answers for this? Can I use 3 bits for representing plus 5 in one's complement format is the question. No, we cannot. Okay, so in our previous sessions we have seen, right? So we need at least 4 bits for representing plus 5 in one's complement format. Okay, now, so that's the reason I'm going to take 4 bits, right? And B is nothing but minus 4. So if I want to represent plus 4, then also I'm going to take 4 number of bits. So it is nothing but 0, 1, 0, 0. And minus 4 in one's complement is nothing but 1, 0, 1, 1. Okay. Now I'm going to add this, which is 0, 1, 0, 1 and 1, 0, 1, 1, which will give me 1, 1, 0, 1, 1, 1, 0, 1, 0, 1. So I'm going to get an n around carry. If I'm going to get a carry, what should I do is I should add this carry to my resultant, which is nothing but 0, 0, 0, 1. That's it. This is my result. And if you're MSB and if you're going to get a carry, that means your number is a positive number. So if you're going to get a carry, if the carry is present, then whatever the resultant you got is a positive, and you need to add that particular carry to the result. And if you get your carry, if you don't get your carry, then it's a negative number, and just perform one's complement on that number, you're going to get your actual result. Okay. Now, let's say if my A is equal to minus 5 and B is equal to plus 4. Let's see this example and let's try to understand what is happening. So, plus 5 is again 0, 1, 0, 1, and plus 4 is simply 0, 1, 0, 0. And if I'm going to add them, and first of all, I need to represent minus 5 in one's complement format of representation, which is 1, 0, 1, 0. And if I'm going to add it 1, 0, 1, 0 and 0, 1, 0, 0, which is nothing but 0, 1, 1. 1. Okay. And over here, if you carefully observe, there is no carry. That means whatever the result I've got is a negative value. Okay. So I can keep minus. And for finding out the original magnitude of this particular number, it is nothing but 0, 0, 0, 1, which is nothing but minus. So this is how you are going to perform addition using one's complement. Is it clear, guys? This is very, very important. And, when we are discussing about some kind of algorithms like Booth's algorithm and different kind of algorithms, this instead of performing subtraction, you can just perform A plus B, A plus one's complement of B. Okay. Yes. Shall we move forward? Any queries or any doubts? Shall we move forward? Okay, great. Now, let's see the same process using 2's complement format of representation. Let's say if I have A is equal to plus 6 and B is equal to minus 3. Okay. And I need to perform A minus B. So instead of performing A minus B, I'm going to perform A plus 2's complement of B. Okay. Now what is that I'm going to get? So for representing my A, I'm going to take four number of bits. So it is 0, 1, 1, 0, and B is nothing but 0, 0, 1, 1, and minus 3 is nothing but in 2's complement it is 1, 0, 1, 1. Okay, I got 1, 0, 1. Sorry, double 1, 0, 1. So which is nothing but 0, 1, 1, 0, double 1, 0, 1. If I'm going to add it, I'm going to get 1 plus 1, 0, 1, 1 plus 1, 0, 1. Here also I'm going to get an end around carry. Now, in the case of my 2's complement format of addition, if I'm going to get an end around carry, I'm going to just discard it. Okay. And since I'm going to get a carry, if the carry is present, yes, then it's a positive number. But if you're not going to get any carry, then it's a negative number. And if the carry is present, you're going to just discard it. You're not going to add it, okay, with your resultant in the case of your one's complement format of representation. But in the case of two's complement format of representation, if you're going to get a carry, you can just discard it, and whatever the result you got is a positive value, which is nothing but plus 3. Okay. Now let's reverse it. Let's say if I'm going to have A is equal to minus 6 and B is equal to plus 3. Okay. So which is nothing but plus 6 is nothing but 0, 0, 1, 1, and minus 6 is nothing but 1, sorry, 0, 1, 1, 0, and minus 6 is nothing but 0, 1, 0, 1, which is 1, 0, 1, 0, and B is equal to 0, 0, 1, 1. So if I'm going to add this 1, 0, 1, 0 and 0, 0, 1, 1, I'm going to get 1, 1, 1, 0, 1, 1, 1, double 1, 0, 1. Here I'm not going to get any carry. That means it's a negative value. So what I'm going to do, it's a negative value. I'm going to perform 2's complement on it, which is nothing but 1, 0, and it is 0. Sorry, this is 1, and here this is 1, 0, 0. This is my final answer, which is nothing but minus 3. Okay. Yes. So this is how you're going to add two numbers using one's complement and two's complement format of addition. Okay. Is it clear for everyone? Any doubts or any queries in this? Okay. Now, let's say, okay, so this was about your addition and all. And for seven's complement and for octal numbers and for hexadecimal numbers, you can follow the same procedure. Okay. Now, anyways, we are going to see that those particular questions in your test. Okay. So tomorrow we will have one more test on morning, 11 a.m. Or okay, let's have it at 11 a.m. Or let's keep a poll like which time slot majority people are okay. So that particular time slot, let's have a test. Okay. Yes. Now, so let's start discussion about something known as BCD codes, right? Can anyone say what do you mean by BCD and where are you going to use it? So if you're learning something, just try to understand like why are you learning it and where are you using it. So what do you mean by BCD code and where are you using it? Anyone wants to answer? If you want, you can also unmute your mic. Binary coded decimal, exactly. BCD basically stands for binary coded decimal. And where are we using it? What is the application of BCD? exactly in 7 segment displays. Okay. So basically, if you are going to represent any particular decimal in BCD format, for each and every particular digit of that particular decimal, you are going to have 4-bit binary equivalent. Okay. So let's say suppose if I'm going to have 1, then if I have a decimal number as 1, then the BCD format of this particular decimal number is 0001. Let's say if I have a decimal number 2, it is nothing but 0010. 3 is nothing but 0011. 4 is 0100. So in the case of your BCD, for each and every digit, you are going to write down 4-bit binary equivalent. Can anyone tell me what is the BCD code for 10? In the case of your BCD counters, real-time clocks. Great, great. Now, can anyone tell me what is the BCD of 10? And the definition of BCD is for each and every digit, you are going to write down 4-bit binary equivalent. So, what is the equivalent of 10? Okay, I got two answers. What about this? Is it 1010? Is it invalid? Is it 0001? 000? What's the answer for this? Okay. Yes. So it's not 1010. Basically, as the definition says, you are going to write down each bit 4-bit equivalent, which is nothing but 0001, 0000. Okay. It's not 1010. No, because as the definition says, for each and every particular digit, you need to write down 4-bit binary equivalent. Okay. And for 11, it will be 0001, 0001. It's not 1011. Okay. And for 12, it will be 0001 and 0010. Okay. And it's not 1100. So if you carefully observe, you totally have 6 invalid codes starting from 1010 to 1111. This particular codes you doesn't exist in BCD format of representation. Okay. So there are basically 6 invalid codes that doesn't exist in your BCD representation. So if you want to represent 11, then you need total 8 bits in case of your BCD representation. That is a disadvantage. If you are going to, if you want to represent a higher value, you need basically more number of bits. Okay. So that is a small disadvantage we have with our BCD format of representation. Okay. Yes. Is it clear for everyone? Any doubts or any queries over here? And let's say suppose if I want to add two BCD numbers, let's say if I'm going to add, let's say A is equal to some 1001 and B is equal to 0001. Can anyone tell me the answer for this if I'm going to add these two BCD numbers? If I want to add this two BCD numbers, which is 1001 and 0001, what is my final answer I'm going to get? 0001. Okay, let's say if I have only 4 bits to represent my BCD number, then and the question is, I have only 4 bits to represent my BCD number. So what is my final answer over here? Is it invalid or is it 1010 or is it 1010? Okay. Sum is equal to 0, carry is C is equal to 1. Okay. Okay. So normally if you're going to add, you are going to get 1010, which is obviously invalid. Just now we have seen that BCD doesn't exist, doesn't have this code, which is an invalid code. Now, if you are adding two BCD numbers and you have the requirement like you have only 4 number of bits, then what you're going to do? Then you are going to just add plus 0110, which is nothing but 6 to make it valid, which is nothing but 1101, 1101. And if you're going to get a carry, then you're going to discard it because you have only 4 number of bits. So this is your final answer. Okay. Because it is present in your range of numbers, exactly, you're going to add plus 6 because you have basically 6 invalid codes. That's the reason you're adding plus 6. Exactly. Okay. So this is how you're going to deal with your BCD numbers. Okay. Now, after BCD, we are going to have something known as gray code and 5421 code and 8421 code and alphanumeric codes and all. I want you to just go through them, and we will have a brief discussion about this. And we have something known as XST code and Hamming code and all. Those we will have a brief discussion, and after that particular discussion, let's have a test on all the particular type of number systems, all the codes included and all, so that you can have a brief, little bit confidence of all these particular number systems, and we can move to the other topic, which is logic gates and all. Okay. Yes. So that's about this particular session. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss with me, or else we can wrap up the session. Okay. Thank you.